All right. Good afternoon, class, or good morning, depending on when you're watching this video. So today is our first day one lecture for Math 208 OAA. That's online asynchronous class. Um, so I wanted to start with this first lecture in part one just to kind of give a little tutorial on what we're going to be seeing in Canvas, where I'm going to be posting things as far as announcements, assignments, grades, so on and so forth. So I'll be going over that today, as well as starting with the lecture material as we start with looking at some of the first few sections of chapter one for this statistics class. All right. So let me go ahead and share my screen as we get started here. Let's see, here we go. Share my screen. All right. So when you first come onto oh, hold on. The cat wants out. Let me let her out real quick. All right. Sorry about that. There was a cat trapped in the room behind me. So now she's out in the hallway and can go as she please. Okay. So Math 208. Um, This is predominantly on this homepage where we're going to see what's happening. You'll see participation questions as they're due will pop up in the coming up section. We'll look at participation day one here in a moment. The course schedule is probably one of the more important things you're going to see on this first page. So if you click on the course schedule, this will show a PDF which gives a breakdown day by day of what we're covering and when we're covering it. So this video is designed for March 17th, day one. And for this video, we're going to cover sections 1.1, 1.2, and 1.3. All right. Now, this video is not focused on the syllabus, but of course, the syllabus tab is here on Canvas, where my mouse is. So you can see everything about the syllabus here. I'm not going to go over all that here in the video, but if you do have any questions about this, feel free to let me know, ask me about it, send me an email, so on and so forth. I do want to highlight here, however, that the office hours for this class, well, of course, you can come in person to my office hours and physically show up my office and ask me questions about the class. Or if you're not on campus or if you're currently living elsewhere in the world, I will also have this Zoom link available for office hours if you want to talk to me over Zoom. So that this Zoom hour will be available during the same times that are scheduled for the office hours. And you just click that link, and then you'll be able to connect with me Monday, Wednesday, Friday, or Tuesdays and Thursdays. Okay, so that is also available for office hours. All right. So for the course schedule, we're going to be going over sections 1.1, 1.2, and 1.3 today. So we're going to look at that here for the lecture material. Now you'll also see, with this being an online class, our homework is done through this online Pearson textbook. All right. So there's this tab here for Access Pearson. This is going to be your primary way of accessing the textbook, so you can look at an electronic version of the textbook and follow along with the textbook chapters as we cover them for this class. There will be step-by-step examples, which we'll talk about in the course, as well as our homework is going to be done through Pearson. So if you haven't done so already, you really need to have access to this Pearson textbook, as this is going to be the way that homework is completed. So if you go to the Assignments tab, and actually let me show this from the student view. Now, when you first go to the Assignments tab, it might by default organize the assignments by date. Personally, I'd recommend click on Show by Type, and it nicely categorizes. You've got the participation questions together, the homeworks together, so on and so forth. This way, it's much easier and quicker to see all the homeworks nicely organized here, okay? In particular, what matters for us, homeworks, and again, looking back at the schedule to reference here, homeworks are always going to be due on Mondays, okay? Um, so the Monday of each week, there will be homework assignments to do, and those assignments are going to be focused on the lecture material from the previous week. So homeworks 1 through 3 is first homework 1 is on chapter 1. We only have one homework for chapter one since chapter one is largely kind of more this definitions kind of chapter where it's just laying out the framework of the vocabulary we're going to use as we continue in the course. Um, and so there's not really so much mathematics stuff or mathy stuff going on in chapter one. It's just definition stuff. So that's just one homework assignment. But towards the end of this week, we will start chapter two on Thursday, sections 2.1 and 2.2. And so those homeworks, homework one, homework two, and homework three, are all due on Monday. Okay. So generally, my suggestion is that after we lecture on something, after we cover it on some day, you want to go ahead and start on that homework assignment so you can be working on the homeworks throughout the week. Whereas if you wait until the day they're due, that becomes a lot of homework to do all in one night, becomes very difficult, more stressful. Bad idea to go down that kind of route. All right. So generally, you want to try to work on the homeworks as we lecture on them so it can be paced throughout the week. And that way you have less to do all in one night on the due date. Okay. I make the due date on Monday so you have that flexibility. This is an online class. And so you have the flexibility of working on the homework when you choose to work on the homework. Okay. But of course, this is a class. We have to make sure the material is completed in a timely fashion. And so Mondays are just the general cutoff day. Homeworks can be completed late, but each day late, there will be a 10% penalty. So 1 day late, 10% off. 2 days late, 20% off. 3 days late, 30% off, so on and so forth. That penalty will stop increasing after 5 days. And so the maximum late penalty you could receive would be 50% off. But that also means at the end of the semester, if you have missing homeworks, you can still go back and do them, get them done. And even if it's a 50 is still a heck of a lot better than a zero. Okay? So you will have that option to go back and work on homeworks if you end up missing them for some reason. Okay? So the homeworks, they're going to be due on Monday. Our first set of homeworks are due this coming Monday on March 23rd. All right? You'll also see from our schedule, there are built-in break days where either we have holidays, be it Easter break or St. Benedict's Day, where we're not going to have any lecture material for those days. So you can take the break or use the day to try to catch up on things if you get a little behind. I will be posting all of these videos for the entire course. I'm a little behind on posting the videos for this class, so I apologize for that. But I will be posting more of them more frequently. And so you will have the option of being able to work ahead if you so choose. Okay. For days when we have tests, and we'll talk about this more as we get closer to it, but for days we have tests, there will be no lecture material, no participation questions. And on those days, there will be a test assignment on Canvas. All right. Now, when that assignment is on Canvas, you will then have that entire 24-hour window. So you'll have the entire day, March 26th, to start test one. So you want to pick whatever time you choose for March 26th, whatever time on that day you want to take test one, then there will be an assignment on that day. You will click the start button. Now, the way the test will work for this class, it is a timed situation. That's just in order to prevent cheating and such. So once you click the start button, then there will be a timer on the assignment where you will have, I believe it's like an hour and a half, something like that, to upload your completed test to Canvas. Okay? We'll have more directions for that as we get closer to that. Our first test is on March 26th. So that will be, well, actually, that'll be Thursday of next week. All right. So I'll be posting more directions for the test as we get closer. But the point is just that when you start the test, it will then be timed, and then you have to complete the test during that time period and then upload the test to Canvas, right? Again, that's just supposed to, with an online class, to cut back on the possibility of any cheating that might be going on. So there's not really enough time to be looking up the questions or to be trying to use ChatGPT to do it for you or something like that. In a time situation, there's just frankly, there's not enough time to cheat, or at least not enough time to cheat and do well on the test. So you do want to study, prepare for the test, just like you normally would for a seated class. Okay. Um, Of course, if anytime you have questions, please feel free to email me or you can message me in the inbox system with Canvas with any, excuse me, with any concerns you might have. All right. So that's all available on Canvas. The assignments are here on Canvas. The participation questions are here on Canvas. Participation day one is due the 17th, so that's tomorrow by midnight. All right. Or at least, well, tomorrow at the time that I'm recording this video. Participation questions, they're always going to go along with the lecture video for that day. So participation day one, again, look at the course schedule. This it goes along with the lecture material for March 17th, and so it also goes with this day one video. There will then be a day two video, which will cover the next few sections of chapter one. That day two video will have a participation question, which is due on March 18th, so on and so forth. So you do have the option of being able to work ahead and complete them before they're actually due. However, participation questions will not be accepted late. So this is just a pacing a pacing tool for the class where you will be kind of required to keep up with the lecture material as we go through the semester. And that way, students don't get behind or end up missing out on the entire course. All right. So you will have to pay attention to this and keep up with this material daily. The thing about this class is that it is an 8-week course, and so it is accelerated. Normally we would have a lecture like twice a week or maybe 3 times a week. But for this class, in order to finish in 8 weeks, we really do have to have material which is covered every day, Monday through Friday. And of course, we do have breaks for holidays and such, but generally, this is going to have to require sort of a daily activity to keep up with the course from here to the end of the class. Okay. All right. Let's see. Anything else I'm missing here? Course schedule, assignments. Oh, also make sure that you have your announcements notification turned on. So announcements is going to be the primary way that I will send out information to you guys regarding the course or updates, information about the tests, so on and so forth, review questions, all that kind of stuff. Um, so it's very important that you are getting the announcements when I post them. And it's a general, just good habit for all of your classes. You want to make sure if you go under your view course notifications, you want to have turned on the announcement notification. And just to make sure that you get an email notification anytime I send out an announcement. That way you're able to receive that information as I send it out to you and you won't miss it that way, hopefully. So that is important. Okay, let's see. Where's Zoom? Here's Zoom. Oh, right, it's in the, okay. All right. So announcements are important. Assignments, we'll talk about participation day one here in a moment. Um, you'll also see on the main page, there are these other videos you can use to follow along as well as reading the textbook. There are also these PowerPoints, which give kind of a step-by-step breakdown from what is also found in the textbook, as well as the dates for our tests, the final exam, all that kind of stuff for this class. All right, so for the textbook, you'll use this tab over here, Access Pearson. So we can go ahead and click on that, open Pearson. And sometimes there's a lot of tabs here you got to kind of click through. Open MyLab and Mastering. From here, now, here you will be able to see the homeworks as well as the textbook itself. Now, for right now, as we're covering this lecture material, I'm just going to go to the textbook, but you can also access the homework assignments here, or you can access the homework assignments directly from Canvas by clicking on one homework, like homework 1, and then it will redirect you to the Pearson link to homework 1. Okay. But for now, we're looking at the textbook, so we can go to the e-text contents. We're looking at chapter 1, section 1.1, e-text. And oftentimes, as we're lecturing on this, I'm going to have this open on a screen, and I'll be sharing my screen. Now, later in the class, as we're actually working through math problems and talking about step by step how to solve those problems, I will switch my camera to just show the room behind me. As I have a whiteboard over here on this side, you can kind of see. The whiteboard I will then use for this class during the videos, and I'll directly write and draw how to solve these math questions step by step. And that will be also included in the video when the camera is switched to it. Okay. But for today, there's not really so much mathy stuff we're doing as this is focused on definitions. Okay. So we're looking at sections 1.1, 1.2, and 1.3. We want to first start with, in section 1.1, what is statistics? What are we trying to do? What are we trying to quantify? What are we trying to talk about? And when we talk about statistics, there's a lot of different things that could be meant by that. We could be talking about the statistics involved in probability. I flip a coin. Do I expect to get a heads or tails? You're making a statistical, you're doing a statistical analysis in your mind as I ask that question about flipping a coin, where you're estimating like, well, what are those statistical likelihoods or probabilistic likelihoods for different outcomes. All right. That could be one application of statistics. Others, or more generally, as they give this definition here in the textbook, oops, as they give this definition in the textbook, statistics in general is the science of data. What you do with that data is an entirely different question, right? I mean, we could talk about I flip a coin, I get heads. Okay, I write that down, heads. I flip a coin, the second toss, it's heads again. Okay, I flip a coin, the third toss. Oh, maybe now it's tails. As I'm doing this experiment, I am collecting data on the results of the experiment. Now, I can later then, as I write down the results and that data is collected, I can then do things with that data. I can try to look at well, what percentage of the results was heads? What percentage of the results was tails? I can create graphs. I can create charts, whether I make a bar graph or a pie chart. Whatever it is, I can then do things with that data, right? But first and foremost, statistics is the science of data where we want to talk about how to collect data sufficiently. One big part of statistics here in chapter one is what is good statistics? What is bad statistics? Does it matter how we collect data? Does it matter how much data we collect? What we find here is that it does matter that we are able to collect good statistics, as oftentimes in the real world, whether we're talking about a weather model that you see in the news on TV or on the Weather Channel or in the weather app on your phone. You want to trust the results of what the weather app says is going to happen. Now, of course, we all know when it comes to the weather, um, you know, sometimes prediction models do a good job and sometimes they don't, right? But regardless, we try to create a good statistical model for what we think could happen, but there's no guarantees, right? Statistics is not a science that gives us guarantees. It's a science which tries to study what could happen and try to, offer a best possible educated guess. All right. So when it comes to data, first we need to collect data. Hopefully, we're collecting data in a good way. We try to classify it, we summarize it, we organize it, analyze it, present it, and interpret this numerical and categorical information. All right. Ultimately, once we do some kind of statistical study, well, if the statistics is important, we want to show other people, right? We want to um, prove to other people what we have found and like, hey, look, it's going to rain tomorrow. You better have your umbrella, right? If we want to convince people that our statistics is good and accurate, well, then we need to make sure it's actually good and accurate. All right. Now, the text here also makes the point of when we're talking about the data we collect, this can be further broken down into two types, what is called numerical and what is called categorical, right? Now we'll get more into this as we continue into chapter one, But essentially, the difference is whether or not the data we're collecting is a number, right? For example, I could be collecting data on the students in this class. And maybe I'm collecting information on, well, how tall are the students in this class? That is a numerical value. If I'm measuring in inches or centimeters or whatever, that is a numerical value, that is numerical information that I'm collecting about the students in this class. In that case, that is the data I'm collecting. Alternatively, I could send out a survey to the class asking, what is your favorite ice cream? I could get vanilla, chocolate, strawberry, whatever. But that is not numerical. If I have 10 students who like vanilla ice cream, then okay, I know then that 10 of the students like vanilla, but the data which has been collected, the vanilla information, is categorical. That is not a number, right? I've collected that you like vanilla ice cream. That is categorical information which has been collected, all right? So we do make the distinction here, in part just because as we continue and we start doing statistical analysis later in chapter 2 and forward, the type of data we've collected is going to limit what we can do in terms of mathematics. If the data we collect is categorical, well, I can't, for example, take an average of all the different results for what kind of ice cream you like. I can't average a type of ice cream, right? But if I'm collecting height, well, I have 5'10", I have 6'2", I have 5'5". I can take all of those numbers and take an average of it, okay? So the type of data that we collect is going to impact what kind of statistical analysis we can perform. All right. So 1.1, this is statistics. As we move into 1.2, we can also further differentiate types of statistics, where we can do what is called descriptive statistics, or we can do what is called inferential statistics. And essentially, the difference is, are you just trying to describe what you have collected, or are you trying to predict what will happen based off of what you have collected? Okay. So for descriptive statistics, I could say, well, all right, I have 20 students in the class, and I find out that 10 of the students like vanilla ice cream. I could create a bar chart where I have 10 students like vanilla, five like chocolate, five more like strawberry. I create a bar graph to represent the data I've collected, and this gives me a visual representation of showing or presenting to others what the data says. In this case, that would tell me that, well, half the class likes vanilla, right? That is a descriptive statistics technique where all I am doing is just describing what has been collected. I'm not making predictions. I'm not trying to make a probability-based guess. I'm just saying, here's what it is. You decide what you think of it. All right. So descriptive uses numerical, graphical methods to look for patterns in a data set. This is done to summarize information which may be revealed. Um, it's also done so that we can present it to other people, so it's more convenient. It's easier for them to digest the information that's been collected. All right. As I create a bar graph, they can then see like, oh, well, if there were 10 vanilla and 5 chocolate, then there are double the number of people who liked vanilla over chocolate. All right. That is then giving a convenient format for them, the audience, to very conveniently, at a glance, look at your graph and understand what has been collected um, in your data. Okay. Inferential is more so think about like a weather model. This is where we're trying to make a prediction. We can collect data off of, well, what is the moisture content in the atmosphere above the sky right now, or in the sky right now? I could collect data on what is the temperature. What is the pressure like outside? Do we have a high pressure front coming in? Do we have a low pressure front coming in? I collect all of this information on what is happening, and then based off of that data, I say, well, we've got a high moisture rate in the sky right now. Temperatures are lower. it's cloudy, we think it's going to rain. All right. Now, again, inferential statistics is not a guarantee of what will happen. It is merely a educated guess, where we're trying to make a best possible educated guess based on the information that's collected, where, well, we think this is the most likely outcome. Again, not a guarantee, just trying to make predictions. All right. So we use data to make estimates, to make decisions, predictions, or other generalizations about a larger set of data. Another example, if we go back to the ice cream situation, say we have 20 students in the classroom, 10 of them in the classroom like vanilla ice cream. The descriptive statistics would be to create a bar graph and say half of the class likes vanilla ice cream. That's true. That's just basically describing what has been collected. But now, inferential statistics would be I could extend that to estimate, for example, for the entire student body at Belmont Abbey College, where I would say, well, based off of this data, I think half of all students like vanilla ice cream. I am estimating what I think is true about the population of all the students. But I don't have that data, right? We collected data for the 20 students in the class, but we did not collect data for the entire college. So I don't know if half of all Belmont Abbey students like vanilla ice cream. I'm making a guess. I'm making an estimate based off of the information I've collected. Okay? So both numerical data and categorical data can be studied in a descriptive statistics way or an inferential statistics way. All right. Um, and again, as we continue in the class, we will see both types of statistics. Early on, we'll be more focused on descriptive statistics. How do we represent data? How do we create graphs? How do we interpret the data we've collected? That's all descriptive. As we continue in the course, and the majority of the course is going to be more focused on the inferential statistics side, as this is really the tricky part of statistics. I can collect data on what's happening in the weather outside right now, but being able to predict what will happen based off of that information, that's a much more difficult question to answer. All right. So we'll talk about some techniques for inferential statistics, um, which will be more focused on the course later in the class. All right, later in the semester. Okay. So we have descriptive statistics and inferential statistics. They give some examples here. I'm not going to go through all of this, and you're welcome to read the textbook here if you like. I'm not going to just sit here and read the whole textbook to you guys for the video, but we'll certainly talk about some of the main examples here. All right. Now, 1.3, we want to make the distinction of when we're trying to do some kind of statistical study, then what is it we're collecting? How do we do that? How do we know if we have a study that's, useful? Well, first, there has to be some kind of experiment involved. Whether it's experiment of I'm going to sit here and flip coins and then I'm going to record what happens. That's one option to collect data. Another option could be, well, I'm going to go around through Belmont Abbey and every student I see, I'm going to stop them and ask them what their favorite ice cream is. While that's not an experiment in the sense of, like an experiment in a lab, it is experiment in the sense of you're going around and collecting information. All right. Or in that case, you could think of it as more of an observational type of experiment where sometimes the experiment is not you actually doing anything. Sometimes it's just collecting information. You want to find out um, what colored fish are in the pond. So you go out to the pond, you look in the pond, and you literally observe what color fish do you see, right? That is a observational type of data collection, all right? And so in general, when we have an experimental or observational unit, this is some object that we are trying to study. I flip a coin. Is it going to be heads or tails? I want to know the favorite ice cream of Belmont Abbey students. Then the students are the object we're trying to study. I want to know what color fish are in the pond. Then I'm studying fish. I could be interested in other things. They don't have to be living things. Maybe I want to collect information on what brand of car do students at Belmont Abbey drive, in which case maybe I want to go out to the parking lot and I'm going to collect information on the cars that are sitting out there. All right. So the unit, the experimental unit or observational unit, is just whatever we're collecting data from. All right. A population is then the entire population of the units that we're trying to study. So take again the example of the favorite ice creams. I'm possibly trying to study the entire population of Belmont Abbey students to find out their favorite ice cream. Now, ideally, if I had enough time and resources, I would go around and ask every single student in the school what their favorite ice cream is. The reality is, especially if some students maybe they don't answer, or maybe they don't want to talk to me, or they just walk away, I might not be able to collect information for the entire student population. It might not be possible. All right. We'll do the best we can. So oftentimes what will happen is that we will have a sample. For example, if I have 20 students in a classroom, which is not the entire population, but we might use that sample to try to say something about the population as a whole. All right. That would be an example of inferential statistics, where we are making an estimate about a greater population that we don't have information on exactly. All right. A variable is the characteristic or property that we are actually trying to study. The experimental unit are the students. But what about the students am I collecting information on? Am I collecting information on their height? That's a variable. Am I collecting information on their eye color? That's a variable. Am I collecting information on their favorite ice cream? That is a variable, right? So a given experimental unit can possibly have many multiple variables. Maybe we want to collect all of them. Maybe we don't. It depends on the situation, whether we want maybe multiple variables we're trying to collect for, or if there's just a single variable we're trying to focus in on. All right. But whatever a variable is, it is some single characteristic or property uh, regarding some object that we are trying to study. Okay. So then a sample, and I got ahead of myself, I said this just a moment ago, a sample is a subset of the population. And they have this example of voters in the United States. Now, at the time of this textbook was written, this is probably outdated, we have 145 million registered voters in the United States. Now, if I'm trying to collect information on these voters, or if I'm trying to, do some kind of statistical study with all of these voters in the United States, it's not really possible for me to go around and collect information on all of these. I mean, okay, maybe if I had the resources, maybe if I had cooperation with all of the states in the country, then maybe each state could collect information and give it back to me, and then I would be able to put it all together. But still, it's a lot of work, right? And so instead, what can be done is we can take a sample of the population where it's not the entire population, it was just some of it. But the hope is that, well, if I study what is happening with the sample, maybe what is happening with the sample is also true of the entire population. Okay. Now, one issue we kind of immediately run into is, well, how do we know if it's a good sample? Or how do we know if it's a bad sample? I mean, right away, one issue with all samples in statistics is a question of, is the sample size large enough? You know, if I'm trying to study the favorite ice cream for students at Belmont Abbey College, and I only ask one student, hey, what's your favorite ice cream? Well, that one student, maybe they like strawberry. Okay. But just because that one student likes strawberry, that sample is so small, it doesn't really tell me anything about the entire student population, right? It could just be dumb luck that it turned out he liked strawberry, that student that I could ask. um, where maybe a lot more students actually prefer other flavors, right? So the size of your sample matters. We want the sample to be large enough that we trust it, um, but we don't want the sample to be too large, otherwise it becomes more difficult to collect the information. So there's kind of this sweet spot between too large and too small, which we'll talk more about later in the course as we continue. But for now, we just want to kind of get through some of this vocabulary in terms of the difference between a sample and a population. All right. So we collect this information. And again, they reference a statistical inference is an estimate, prediction, or some other generalization about a population based on information contained in a sample. All right. I collect a sample. I study some variable that we have collected in that sample. And based off of what's there, I make a guess. I make an estimate, a generalization of, well, I think this is true of the population. It's not necessarily true, right? This is an estimate, but it's supposed to be a best possible educated guess. That's what we're trying to do here with inferential statistics. All right. Now they give some other examples here where in this first example, 1.1, according to Variety magazine, the average age of Broadway ticket buyers is 42.5. All right. Suppose a Broadway theater executive hypothesizes, so he's making a guess, he's making an estimate, that the average age of ticket buyers to her theater is less than 42.5. Now, does she have a reason to make that guess? We don't really know here, but that's the guess that she is making. To test her hypothesis, she samples 200 ticket buyers to her theater's plays and determines the age of each. So the population as a whole, we're trying to study these ticket buyers. In particular, for this lady, um, well, we're looking at the Broadway ticket buyers, right? Now, she can't collect information on all of them. There may just be too many, right? Instead, she samples 200 of the ticket buyers, records their age. So the population is all of the ticket buyers. The sample, well, it's the sample of these 200 that she collects. The variable of interest, their age. How old is each person in this sample? And then what's the inference here? Well, she's guessing. Now, in this case, she's making a guess before the sample has been even collected. All right. This can be done in statistics and oftentimes is done in science in general, where we form a hypothesis, we go and collect data, and then we check the inference against the data. Does the data support the inference or does it not? So sometimes we make an inference before the data is collected. Sometimes we make an inference after the data is collected. All right, it just depends on the situation and what we're trying to do. Um, but we do have this kind of simple example that is nicely utilizing all of these kind of vocabulary terms that we've talked about so far. Okay. They do give some other examples as well as the answers. I'm not going to go through all of that right now, but you can see that in the textbook here. All right. Now, one of our last concerns here for section 1.3 is reliability. Since after all, I collect this data, I make a prediction. We're going to have a purple sun tomorrow. Okay. But without any data or without presenting the information, people are going to look at me and be like, why? Why do you think that? Can I provide information which is reliable enough for them to believe me that like, oh yeah, I guess the sun will be purple tomorrow, right? Now, I'm intentionally making up an outlandish example, but the point here is just that when you give a statistical presentation, you want it to be reliable. You want it to be trustworthy. Otherwise, who's going to care what you're saying, right? You need your information to be reliable. So, in general, a measure of reliability is some statement about the degree of uncertainty associated with the statistical inference. All right. You see this with rain models, where people will predict, I think it's going to rain tomorrow. And then they'll say, yeah, there's a 70% chance of it. All right. That's telling you how reliable that information is. That's also telling you, well, there's a 30% chance it's not going to rain at all. Or if I tell you, well, now there's a 99% chance it's going to rain tomorrow. Well, then, okay, now you're more certain, you have a higher level of reliability that, okay, this information is true, it's going to rain, I need to prepare for it. So the higher reliability we have, the more trustworthy it is, the more likely people are to believe it. If we have lower reliability, then, well, okay, probably less helpful information, right? Now, we also see here at the end of the section where they give a breakdown of the difference between descriptive statistics versus inferential. Both may have a target population or a target sample that we're trying to study, that we have an interest in. Both have a variable that we're trying to collect information on. It could be numerical. I'm collecting the height of people. It could be categorical. Maybe I'm collecting eye color on people. All right. Where we have differences is what we do with the data that's collected. For descriptive data, all I'm doing is just trying to describe what I have collected. I make a table. I make a bar graph. I make a pie chart. I, in some way, just show you what my sample says, what has been collected in my sample, and I try to identify patterns. The difference here is descriptive, there's no guesswork, right? It's just 100% true, right? If I have 20 students and 10 of them like ice cream, it is a fact half of my class likes ice cream, right? Or likes vanilla ice cream. It becomes inferential when I try to extend that information to a larger population. So inferential statistics, I have the same components as before, except now I'm making an inference. I'm making a guess. I'm making an estimate, which we don't know if it's true necessarily. It's just an educated guess. And lastly, inferential statistics has a measure of reliability indicator. How true is it? How confident are we in what we have found? I can say, oh, well, I am 80% confident that it is going to rain tomorrow. All right. Again, it's a prediction, it's an estimate, it's not a fact. All right. So, inferential statistics, we're making predictions which may or may not actually happen. We hope it happens. We try to make as good a guess as possible, but it's not guaranteed. Whereas descriptive, all we're doing is just describing the data which has been collected. We're not making any kind of predictions. All right. They give some other examples here, and that will wrap up what we're looking at here in sections 1.1, 1.2, and 1.3. All right. Now, this video in particular is going to be a little bit shorter, and these first few as we start in chapter 1 are going to be a little bit shorter, as you've seen here in this video. This is just definitions, right? What is statistics? What is a variable? What is the population? What is a sample? So on and so forth. We're not really doing any math yet. We will. And when we get there, as promised, I'll do it on the whiteboard here in my room. But for now, and for this early part of the course, we're going to be just focused on this definition stuff. And then we'll do more mathy stuff later. Now, the last thing with this video is the participation question, all right? Now, as promised, this is always going to be covered in the video. So if you're watching these videos, these participation questions are a free 100. We're always going to talk about it. All you got to do is watch through the video, find the answer, type it into Canvas, you get 100, okay? The purpose of the participation question is not to be like a difficult thing. It's supposed to be a free 100 for everybody who is responsibly keeping up with the class. And that way you're rewarded for keeping up with the class. And that then will also, because participation is 10% of our grade, that's giving you a free 10% towards your grade. Okay? All right. What are we looking at here? So we have a survey is taken of 100 Belmont Abbey College students. asking them about their favorite ice cream. All right. So we're trying to study maybe something about the entire student body, but okay, let's continue reading. The results of this survey, so from the 100 students, is then displayed in a bar chart where each bar indicates how many students voted for each answer. And that's it, right? They're not making a prediction, they're not making an estimate. They're just saying, here's the information displayed. Do what you will with that information. Okay? So there's no prediction, right? There's no estimate going on. This is just a fact of what does the survey say, right? So it is not inferential. This is, in fact, descriptive statistics. So to get credit for today, participation day 1 here, you'll go to Start Assignment. A text box will appear. Just type in the answer. You don't have to type in like a big, lengthy explanation or anything like that because we do that here in the video, right? All you have to do is type in the correct answer and you'll get credit. So for today, is this descriptive or inferential? This is descriptive. Oops, my keyboard is not working. What's wrong with my keyboard? Um, oh, that's weird. My keyboard disconnected from the computer. Um, okay. Keyboard is back in. So this is descriptive. So I will type descriptive. All right, that is my answer. I don't need to do more than that. Just come down and hit submit. And then great, you will receive credit for today's participation question. All right. So that's all we have for this video. The future videos will also be posted. If you have questions, feel free to email me, come by office hours, reach out to me whenever you need help. Otherwise, best of luck, and I guess I'll see you in the next video. All right. Have a great day.